Hello everyone, I hope you are having a great day. Today we're going to be talking about a new topic, and that is linear inequalities. So this is really going to be putting together two things that we've already learned this year. First, we're going to be dealing with inequalities, so what we did in chapter 2. So like greater than, less than, and so on. And we're going to be putting in our linear equations. So we're going to combine all of those together. And so this is what a linear inequality looks like. And so you can see it's really similar to our linear equations that we've been working with all last semester, except instead of an equal sign, I have an inequality in there. And so for this first question, it asks me to tell whether the ordered pair is a solution of the inequality. And so what I am looking to see is whether when I plug this point in, do I get a true statement at the end, or do I get a false statement? If it's a true statement, then that means it is a solution. If it comes out being false, then it's not a solution. And so here I have the point -2, 4. I know for all of my ordered pairs, my x is first, my y is second. So now I want to plug that into my linear inequality here. So instead of y, I'm going to put 4. It's less than 2 times, instead of x, I'm going to put -2. 2 times -2, I get -4. And then -4 plus 1, I get -3. Now I need to read that and see if that is true or false. Well, this tells me 4 is less than -3. Well, I know that's false. 4 is actually bigger than -3. So that means that this is not a solution. Okay, let's try the next one. So 3 is x, 1 is y. So instead of y, I plug in 1. Instead of x, I plug in 3. 3 minus 4, I get -1. 1 is in fact greater than -1. That is a true statement, so that means that this is a solution. So in the next video, we're going to be graphing these, and this table here is going to really help you in figuring out how to shade. So for the first inequality, I have a less than. And for these linear inequalities, these are a little bit different from graphing just regular equations, because we're actually going to have two different line types. The first one is we'll have a dashed line. So literally just means when I graph my line, it is dashed. And that is when you have a strictly less than. And for when we're graphing these, we're also going to be shading, and that shading is going to represent our solution area, so all the points that satisfy that inequality. And for a less than, we're going to shade below the line. So an example of what this would look like is, there's my dashed line, and I shade below it. Okay, next one for a greater than, that is also going to be dashed. But for a greater than inequality, I'm going to shade above the line. So what that would look like, I have my graph here, I have my dashed line, but if it's a greater than, then I'm going to shade for everything above it. So those are for the greater than and less than. They're both dashed lines. But now for the greater than or equal to and the less than or equal to, those are both going to be solid. So they're going to look like our normal lines that we've been graphing here. And so one way to differentiate between the two, to remember, is that this greater than or equal to and less than or equal to, they have that line underneath. So you may want to like draw little arrows. Remember, okay, that means solid. When there's a line underneath, it's solid. And so just like before, if it's greater than or equal to, so just like the greater than, you're going to shade above the line. So an example of what that would look like is this. So it's very similar to that one, except it has a solid line. And for less than or equal to, you're going to shade below the line. So anything with less than, you shade below. Anything with greater than, you're going to shade above. And so those are some examples of what all those look like. And so in summary, to determine solutions when looking at a graph of a linear inequality, it's going to be all points in the shaded, or in the region shaded by the inequality. So like for this graph right here, any point that is in that shade is a solution. It also includes the points on the solid boundary line, but not on the dashed. So looking at this example again, a point on this line would be a solution, but a point on this dashed line would not be a solution. And the reason why, it's because of the or equal to part. So for instance, one of these points, let's say it ends up being, if I plugged in that point, it ends up being 3 is less than or equal to 3. That is a true statement because of that or equal to. 3 is equal to 3. Where for the one above, 3 less than 3, that is not true. 3 is not less than 3. So solid lines, the boundary is part of the solution. Dashed, it is not. Okay, that is it for this video. You can go ahead and move on to the next one.